All right, welcome to the fourth part of the AWS AI Practitioner walkthrough. We're going to go over some questions, some answers, and some analysis with some explanations. Before that, though, remember to like, subscribe, and share this with anyone you know who might be taking that exam. This will help with your future, especially as AI gets moved into more workloads. So let's get started. First question. An insurance company is transitioning to AWS Cloud and wants to use Bedrock for product recommendations. The company wants to supplement organization-specific information to the underlying foundation model. Which of the following represents the best fit solution for the given use case? Use knowledge bases for Bedrock to supplement contextual information from the company's private data to the foundational model using RAG, Retrieval Augmented Generation. So why is that correct? So Bedrock lets you extend the capabilities of foundation models using knowledge bases. This implements RAG, and this lets a foundation model pull in relevant real-time contextual data from your private sources, like your company documents, any FAQs or product catalogs during inference. So RAG enhances the relevance, factuality, and customization of outputs without needing to fine-tune the model or retrain it from scratch. All right, why are the other answers incorrect? Reinforcement learning, human feedback. So this is incorrect. Knowledge bases uses RAG, not reinforcement learning from human feedback, RLHF, right? RLHF is used during model training. So it's pre-deployment, and it's not part of Bedrock's knowledge-based pipeline. Fine-tuning the base model. All right, so this is misleading. You can't fine-tune the base model itself. Instead, Bedrock lets you fine-tune a separate copy, a custom model. So fine-tuning is more resource intensive, and it's not necessary for this use case, especially if the goal is to add organization-specific data for recommendations. And then implement RLHF and Bedrock by leveraging contextual. Okay, so you can't implement RLHF directly in Bedrock. It's a training technique used by foundation model providers. So think like Anthropic, OpenAI, Amazon, etc. RLHF is not exposed as a user configurable option in Bedrock, at least not today. All right, next question. A healthcare company is developing machine learning models to analyze both structured data, such as patient records, and unstructured data, such as medical images and clinical notes. The data science team is working on future engineering to extract the most relevant information for the models, but is aware that the process differs depending on whether the data is structured or unstructured. To ensure they approach each data type correctly, they need to understand the key differences in feature engineering tasks for structured versus unstructured data in the context of machine learning. What is a key difference in feature engineering tasks for structured data compared to unstructured data in the context of machine learning? Feature engineering for structured data often involves tasks like normalization and handling missing values, while for unstructured data, it involves tasks like tokenization and vectorization. All right, so why is this correct? So structured data handles missing data, normalizing, and one-hot encoding categorical variables, right? So it neatly organizes this into rows and columns, all right, with feature engineering. Unstructured data requires more complex transformations. That means text has to be tokenized and stemmed and vectorized, right? So this has word embeddings and all these different types of vectors, right? Images need pixel normalization and edge detection, right? This is a feature extraction during any CNN. So why are the other answers incorrect? That can help you out a little bit more. So feature engineering for structured data is not necessary as the data is already usable. Okay, so even tabular data needs pre-processing. Think of the missing values, any outliers, any feature scaling, right? So this downplays critical pre-processing that's required for structured data. Feature engineering tasks are identical and do not vary. Okay, so that's false. Okay, so feature engineering tasks vary significantly by data type. They're structured with columns, like column-based statistical transformations, or unstructured, which would be complex signal, text, and image transformations. Right, and then feature engineering for structured data focuses on image recognition. Okay, so this reverses the correct association, right? So unstructured data includes image data and requires CNN-based feature extraction. And then structured data is tabular and rarely relates to image recognition. Okay, next question. A retail company is embarking on a machine learning project to enhance customer segmentation and personalize marketing campaigns. As the data science team begins planning the implementation, the team wants to identify the primary challenges in machine learning implementation. Understanding these challenges will help the team anticipate potential roadblocks and develop strategies to overcome them. Which of the following represents the best option for the given use case? Difficulty in collecting and preparing high quality data for training models. Okay, so why is this correct? So one of the most significant and well-documented challenges in applying machine learning in real-world scenarios is ensuring data quality and preparation. So machine learning models are only as good as the data they're trained on. So real-world data sets are often messy, incomplete, inconsistent, or biased. So there's certain tasks like data cleaning, handling missing values, removing noise, labeling or annotating data, especially if supervised, and in pre-processing and normalizations that are critical before even training the model. All right. So remember that machine learning requires high quality data to function effectively. One of the most common challenges is preparing and labeling large volumes of training data. Why are the other ones incorrect? So limited applications of machine learning in real world scenarios. No, that's inaccurate. So machine learning is widely used across industries. You think of like retail, healthcare, finance, manufacturing. Applications include recommendation systems, right? So this could be something for like a fraud detection system in the finance sector, or diagnostics in healthcare, right? Or autonomous systems within manufacturing. All these things can be applied. Insufficient computational power to run basic machine learning? No. So basic ML models, right, can run on commodity hardware, right? So cloud-based platforms can provide scalable compute. That's why we're talking about AWS AI Practitioner. And computational power is a secondary challenge for most teams. And then a lack of available machine learning algorithms? No. So there's a huge ecosystem of algorithms already available, right? There's classification types that do logistic regressions or random forest. There's regression, clustering, neural networks. The challenge is choosing and tuning the right one, not their absence. Okay, next question. A technology consulting firm is advising a client on implementing advanced AI-driven solutions for automating business processes and improving decision-making. The client wants to understand the hierarchical relationship between different AI technologies, including artificial intelligence, machine learning, and deep learning, and generative AI, to determine how each fits into their broader technology strategy. Gaining clarity on this hierarchy will help the client prioritize investments and understand how these technologies interact. Given this context, what is the correct hierarchical relationship between artificial intelligence, machine learning, deep learning, and generative AI? C. Okay. Artificial intelligence, then machine learning, then deep learning, then generative AI. All right. So why is this correct? So the hierarchical relationship reflects how these technologies build on each other. So the umbrella term is AI, artificial intelligence, right? This is the term for systems that mimic human intelligence. This is stuff like decision-making, reasoning, and problem solving, right? And then there's machine learning. This is a subset of AI that focuses on enabling machines to learn from data and improve over time without being explicitly programmed. And then even deeper is deep learning, which is a specialized subset of machine learning that uses neural networks with many layers, enabling more complex pattern recognition. And then there's a further subset of deep learning focused on creating new content that would be text, images, music, etc., based on learned patterns. So why are the other answers incorrect? So A. So this reverses the pattern, right? Gen AI is a subset of deep learning, not the parent of AI. Okay. And then let's see, why is B incorrect? So machine learning is not broader than AI. It's a subset. The order is factually incorrect. And then D, why is this incorrect? So Gen AI is not broader than machine learning. It's a specific application under deep learning, which itself is under machine learning. All right. Next question. The development team at a company needs to select the most appropriate large language model for the company's flagship application. Given the vast array of LLMs available, the team is uncertain about the best choice. Additionally, since the application will be publicly accessible, the team is concerned about the possibility of generating harmful or inappropriate content. Which AWS solution should the team implement to address both the selection of the appropriate model and the mitigation of harmful content generation? Select 2. Guardrails for Bedrock. Model evaluation for Bedrock. All right, why are these correct? So model evaluation. So this helps teams evaluate and compare foundation models to determine the most suitable one for a specific use case, right? That could be summarization or classification, right? This includes setting up evaluation metrics and using predefined or custom test data sets and integrating results into your development workflows. So it directly supports model selection by helping determine the best performing model for the application's needs. And then guardrails. Okay. Guardrails allows developers to enforce content safety. You can apply these policies for harmful or biased responses and enforce output moderation. This includes filters for profanity, hate speech, violence, PII, and other sensitive content. And it can be applied across multiple models. So it directly addresses the needs for moderation of generated content in public applications. So why are the other ones incorrect? Okay, SageMaker Model Monitor. All right, this is a tempting one. So this focuses more on monitoring drift in production machine learning models, but not necessarily selecting or evaluating LLMs or moderating Gen AI outputs. So pay attention to that. The monitor is there to distract you. Okay. SageMaker Clarify. All right. So this is incorrect because it's designed to detect and explain bias in tabular data machine learning predictions. It doesn't assist with model evaluation or response safety. Okay. And then comprehend. So this is just another service, right? This is a service for entity recognition, sentiment analysis and topic modeling, and static text. It's not used for LLMs, model selection, or content-based safety moderation. Read the question carefully, all right? Next question. A software development company is exploring Amazon Q Developer to enhance its internal tools and workflows. The company is particularly interested in leveraging the platform's capabilities to automate code generation, improve task automation, and integrate machine learning features into its applications. To understand how Amazon Q Developer can support these objectives, the development team needs a clear overview of its core functionalities. Which of the following represents the capabilities of Q Developer? Select 2. Understand and manage your cloud infrastructure on AWS, and get answers to your AWS account-specific cost-related questions using natural language. All right, why are these correct? So understanding your cloud infra and managing it. So Q Developer enables developers to query AWS infrastructure using natural language. So it can help them list, describe, explore AWS resources like Lambda, EC2s, IAM roles, and it'll streamline AWS operations by minimizing the need to navigate to the management console or manually look through documentation. All right, and then get answers to your AWS specific cost-related questions. Okay, so Q Developer integrates with Cost Explorer. So it lets developers ask natural language questions like, what was my EC2 spend last month? Or what did my S3 costs why did my S3 costs increase? While it doesn't visualize the data, it summarizes and retrieves insights in plain language from cost data sources. So why are the other answers incorrect? Okay. So modify your AWS resources. Okay, so Q Developer is read-only and does not perform modifications actions like resizing or stopping instances. All right. Visualize your account specific. No. So visualizations are not part of Q Developer. Those are done in Cost Explorer. Q Developer provides text-based answers, not charts or dashboards. And then deploy your cloud infra on AWS. No. So Q Developer does not execute deployment actions like Terraform apply or AWS CloudFormation deploy. It only assists with understanding existing infrastructure. All right. Next question. A healthcare company is considering migrating its on-prem infrastructure to AWS Cloud to enhance data management, improve scalability, and reduce operational costs. The leadership team is new to cloud technologies and wants a clear understanding of what cloud computing entails, specifically how AWS defines and implements it. This understanding is essential for the company to make informed decisions about the benefits and use cases of cloud computing in their operations. Given this context, what is cloud computing as defined by AWS? Right? So cloud computing refers to the on-demand delivery of IT resources and applications via the internet with pay-as-you-go pricing. So why is this correct? All right. So this is it. This is a very straightforward one. All right. So cloud computing is defined by AWS is on-demand delivery of IT resources, right? With pay-as-you-go pricing. So it helps organizations with eliminating capital expenses of buying hardware, scaling infrastructure dynamically, reducing time to deploy, and improving the availability and agility of their environment. Why are the other ones incorrect? This can usually help you. All right. So cloud computing is a practice of using open source software. No, that's incorrect. That's misleading. AWS supports both open source and proprietary solutions. The definition of cloud computing is unrelated to the licensing model of software. So cloud computing involves manually managing physical data centers. That's incorrect. Okay, so one of the advantages of cloud computing is that AWS manages the infrastructure, letting customers focus on applications and services rather than the hardware. And cloud computing is the process of using a single local no, single local server. No. So this describes a traditional on-prem setup, not cloud computing. Cloud computing uses a network of servers to deliver scalable, redundant, and distributed systems. Okay, next question. A technology consulting firm is advising a client on the use of AI to enhance their business operations, particularly through the implementation of large-scale models that can handle diverse tasks like text generation, image recognition, and natural language understanding. The firm is evaluating foundation models as a potential solution and wants to clarify their capabilities, including their ability to generalize across multiple domains and perform a wide range of tasks with minimal fine-tuning. Which of the following options aptly summarizes the capabilities of foundation models? Okay, so that'll be D. Foundation models can perform a wide range of tasks across different domains by leveraging their extensive pre-training on large data sets. So why is this correct? So foundation models are pre-trained on large-scale data sets, and they're capable of generating or generalizing across domains. And they can perform a lot of downstream tasks like text generation and summarization, natural language understanding, code generation, image recognition and captioning, conversational AI, right? So they use self-supervised learning and deep neural networks to infer patterns and context. So this lets you enable multimodal and multitask generalization with minimal fine tuning. Why are the other ones incorrect? Because the foundational models are limited to simple data processing tasks? No. Okay, so foundational models are specifically built to handle complex tasks like reasoning, summarization, translation. Foundational models are designed to work exclusively with structured data and can't, no. Okay, so foundational models are especially powerful with unstructured data, including text, images, audio, video. All right. Foundational models can only perform a single task they were specifically trained for. No. So this applies to traditional machine learning models. Foundational models are multitask capable due to their pre-training on large and diverse data sets. All right. Next question. A healthcare startup is developing a machine learning model to predict patient outcomes based on historical medical data. During the training process, the data science team notices signs of overfitting, where the model performs well on the training data, but struggles with new, unseen data. To ensure the model generalizes effectively and avoids memorizing the training data, the team needs to implement strategies to prevent overfitting. How can you prevent model overfitting in machine learning? So D, by using techniques like cross-validation, regularization, and pruning to simplify the model and improve its generalization. So why is this correct? Well, overfitting occurs when a model learns not just the underlying patterns, but also the noise in the training data. So this results in a poor generalization to unseen data. The following methods help combat this. Cross-validation, okay? So this helps verify model performance across different data splits and improves generalization. Regularization. Okay, techniques like lasso and ridge penalize overly complex models. And then pruning. So pruning is used in decision trees to remove branches that do not provide meaningful information. These all balance the model's complexity and accuracy, making it more robust to new data. Why are the other options incorrect? So by avoiding any form of model validation or testing to prevent the model from learning. Okay, so validation and testing is essential, right? If you need to, this is good for assessing how well a model generalizes. Avoiding it increases the risk of overfitting undetected information, right? By increasing the complexity of the model to ensure it captures all nuance in the so more complexity increases the risk of overfitting, as the model may start memorizing the data instead of learning patterns. Only training the model in a small subset? No. So training on less data often leads to underfitting, not a solution for overfitting. Okay. A healthcare startup is building machine learning models to assist doctors in diagnosing medical conditions. The development team is debating whether to use a complex, high-performing model or a transparent and explainable model that offers clear insights into how predictions are made. Since transparency is important in healthcare, the team needs to weigh the benefits of using an explainable model, particularly in terms of trust, compliance, and accountability. Which benefits might persuade a developer to choose a transparent and explainable machine learning model? So this is looking like C and D. Facilitate easier debugging and optimization, and D, they foster trust and confidence in model predictions. So why are these correct? So facilitating easier debugging. Okay, so transparent models like decision trees or linear models allow developers to trace how features impact predictions. This visibility makes it easier to identify logic errors or quality data issues, um, adjust features or parameters, tune performance for fairness and accuracy, and fostering trust and confidence. Okay, so in a regulated domain like healthcare, understanding the why behind predictions really helps, especially with a couple things like meeting compliance and audit requirements, letting clinicians and stakeholders use use trusted AI to assist in diagnosis and to support accountability and critical decision making. So why are the other ones incorrect? They enhance security by concealing model logic. No, no, no. So transparent models reveal how decisions are made. This is the opposite of concealing logic, right? This may actually reduce model security in sensitive use cases. Simplify the integration with other system processes. No. So integration is primarily driven by API design. So the deployment architecture, system compatibility, API design, right? Not by model transparency, and they require less computational power and storage. Okay, so resource usage depends on the model type. Think linear versus deep learning, right? Also, it depends on data size, training requirements, not strictly on whether the model is transparent. All right, next question. The company is a chatbot powered by Bedrock to handle customer inquiries and support requests. While the chatbot is effective at providing automated responses, the company has noticed that some of the replies do not consistently match its desired tone. Professional, empathetic, and friendly. To maintain brand consistency and ensure a positive customer experience, the company needs to align the chatbot's responses with its specific communication style and standards. Which approach would be most effective for ensuring the chatbot's responses are consistently aligned with the company's tone and style? Okay, so the chatbot should iteratively test and adjust the chatbot prompts to ensure that its outputs consistently reflect the company's tone and style. So why is this correct? Prompt engineering is the foundational approach to shaping the behavior of Gen AI, especially in Bedrock. By iteratively testing and refining prompts, developers can include examples of desired tone and phrasing. They can use system instructions to guide the AI toward a consistent style, and they can improve the tone alignment over time using feedback loops. Okay. And why are the other options incorrect? Okay, the company should set a low limit on the number of tokens. No, so this controls the response length, not the tone or style. This might unintentionally truncate helpful or empathetic phrases. Companies should use batch inference. So this improves throughput and efficiency, but not response quality. It's not related to how the model interprets tone or phrasing. Adjusting the temperature to reduce the randomness. No, so this influences the creativity and diversity, right? Think of that 0 to 1 scale for everything. Well, a lot of these parameters. This doesn't guarantee alignment with brand tone or values. Okay. Next question. A media company is developing generative AI applications on AWS to automate content creation and enhance customer engagement. Given the sensitivity of customer data and the complexity of AI models, the company's security team wants to implement a defense in-depth security approach to protect both the data and the AI infrastructure. Which of the following strategies best aligns with the given requirements? Okay. Applying multiple layers of security measures, including input validation, access controls, and continuous monitoring to address vulnerabilities. All right. So why is this correct? Yeah. So the defense in depth strategy, that input validation, right? That means preventing prompt injections and harmful user input. Access controls, that would be using stuff like IAM, least privilege, and MFA to restrict access. And then continuous monitoring would be using tools like CloudTrail, GuardDuty, Bedrock, guardrails to track abnormal behavior and security breaches, right? So this layered approach aligns with the OWASP top 10 for any LLM and meets AWS's security guidelines for Gen AI. And so why are the other answers incorrect? Okay, so single authentication mechanism for, oof. Okay, so that lacks granularity, and that is a lot of lateral movement if it's compromised, right? So the best practices recommend stuff like identity federation, RBAC, role-based access control, and multi-factor authentication, MFA. All right, relying on data encryption solely, no. So Encryption at rest and in transit is necessary, but insufficient. So it doesn't protect against model misuse, prompt injection, or improper access control. And then implementing a single layer firewall to block unauthorized access. No. So firewalls protect the network perimeter, but don't prevent application level threats. So defense in depth requires network, application, and identity layer security. Okay. Next question. A retail company is developing a machine learning model to predict customer churn and is in the process of preparing its data set. The data science team plans to divide the data into a training set, validation set, and test set to ensure the model performs well across different stages of development and evaluation. To proceed effectively, the team needs to fully understand the roles of each of these sets and how they contribute to building a robust model. Which of the following is correct regarding the training set, validation set, and test set used in the context of machine learning? Select two. So validation sets are optional. And then test sets used to determine how well the model generalizes. Okay, so why are these correct? So a validation set is used during training to tune hyperparameters and evaluate model performance before final testing. Okay, while extremely useful, it's not strictly required. Some workflows may skip it, especially in simple models or when using techniques like cross-validation. Okay. And then the test set is used to determine how well the model generalizes. So the test set is held out until the very end and is used to assess the model's performance on unseen data and ensures it generalizes well beyond the training and validation data. So this provides a final, unbiased evaluation metric. So why are the other answers incorrect? So validation set is used to determine how well the model generalizes. Okay, so this is incorrect, right? Because the test set, not the validation set, is used to measure the generalization. The validation set is used during model development for hyperparameter tuning, okay? So remember that positioning and the order. All right, so test set. Test set is used for hyperparameter, no. So this would lead to data leakage and biased performance metrics. So hyperparameter tuning should occur on the validation set, not on the test set. Okay, test sets are optional. So test sets are essential to evaluate real world performance. Skipping a test set can lead to overfitting without even realizing it. Okay. Next question. Companies using Amazon Titan text model with Bedrock. Which of the following scenarios is the model most likely to hallucinate? When the temperature is set to 1? Okay, why? The temperature parameter controls the randomness and creativity of a Gen AI model's outputs. The higher the temperature, say 1 on the 0 to 1 scale, this allows the model to generate more diverse and creative responses. But it also increases the risk of hallucinations, where the model generates content that might be inaccurate, fabricated, or not grounded in the data, right? So this is especially relevant when using Titan text with Bedrock, right? Where prompt engineering combined with temperature settings directly impacts output quality. So are the other answers incorrect? When the temperature is set to 0? No. When it's set to 0, it'll be more deterministic and have more reproducible results. So the model always picks the highest probability token here, and it reduces the chance of hallucination. When the temperature is set to 0.5? No. So a moderate temperature strikes a balance between creativity and accuracy, and it can still keep hallucination risks pretty low. And the temperature has no impact on hallucination. That's incorrect. All right. So temperature does impact how much creativity the model takes, right? So higher temperature means randomness, leading to greater hallucination risk. Just remember that. Okay, so next question. A retail company is developing machine learning models on AWS to improve product recommendations and customer insights. To ensure consistency and collaboration among its data science team, the company needs a solution for storing, sharing, and managing the inputs used during the model training and inference phases. The company is evaluating AWS services that can help streamline this process. Feature store. All right, why? So feature store is correct because it's a purpose-built managed repo for storing, sharing, and managing features used in machine learning. These features are key input variables. This could be like the customer age, the product category, browsing history, used during the training and the inference, right? So this supports the collaboration and consistency that allows shared access to curated features. And the feature store ensures that features used for training are also available at inference time. So it avoids training serving skew, right? And then it also supports ingestion from sources like S3, Redshift, Lake Formation, Databricks. It's very robust. So why are the other answers incorrect? This can usually help for this type of question. Ground truth, all right? Ground truth is used for data labeling with humans in the loop, right? It supports supervised learning setups, but it does not have any features in a repo. That's what you're really looking for. All right, data wrangler. So this is for data prep, cleansing, and transformation. This helps in engineering features, but it does not store or manage features for your use. Okay, and then SageMaker Clarify. So this is used to detect bias and explain model predictions. It's not used for feature storage or collaboration across training or inference pipelines. All right, so sometimes it's in the name. Remember that. Next question. A fintech company is looking to improve its software development lifecycle by adopting cloud-based solutions that allow for faster innovation and more efficient deployment of new features. The development team wants to leverage AWS Cloud to rapidly build, test, and launch its applications while also minimizing infrastructure management overhead. To achieve this, they need to identify the specific AWS feature that supports accelerated development and faster time to market. Agility. All right. So agility is a core benefit of cloud computing, particularly in AWS. It refers to the cloud's ability to enable faster innovation and rapid development, testing, and deployment of applications without being bogged down by traditional infrastructure provisioning. So a couple key points, right? AWS has immediate access to a broad set of tools. That could be compute, storage, AI, analytics. And with this, you can experiment, you can iterate, and you can deploy software quickly. So this reduces your time to market, which is essential for any agile software delivery in fintech or any other fast-paced sector. All right, why the other answer is incorrect? Elasticity. So this means scaling resources up and down as needed. So it supports efficiency, but not directly addressing speed of innovation or rapid development. Okay. Ability to deploy globally in minutes. Okay, so this is talking about reach and latency. It helps performance and user experience, but it's not the primary benefit tied to development speed or innovation. Sorry, I thought I was going to sneeze. Okay, cost savings. So cost efficiency is an important benefit of cloud adoption. All right. However, cost savings alone does not guarantee faster development or deployment. Okay. Next question. A healthcare technology company is developing AI-driven applications to assist doctors in diagnosing diseases. As part of its commitment to ethical standards, the company wants to ensure that its AI models are fair, transparent, and free from bias. To achieve this, the data science team is exploring AWS services and tools that can help implement responsible AI practices, as understanding which AWS service supports these practices is critical for the company's AI development strategy. So this is SageMaker Clarify and Model Monitor. All right. So why are these correct? So SageMaker Clarify is all about fairness and transparency, especially in machine learning, right? So this detects bias in data sets and model predictions, generating explanations of model outputs, and then it's integrated into the model lifecycle from data prep to deployment. And then Model Monitor helps implement continuous governance of AI models, right? It detects data drift, model quality issues, and bias. And then there's automated real-time alerts if the model deviates from expected behavior, and allows for traceability and auditability of predictions. All right, so why are the other ones incorrect? So Jumpstart. So Jumpstart is this is for good pre-built models and templates for quick machine learning deployment. It doesn't include tools for monitoring fairness, bias, or responsible AI, not directly at least. An inspector, no. So this is a security focused service. So this identifies vulnerabilities in EC2s, containers, and lambdas. It's not related to machine learning, fairness, or responsible AI. And an audit manager. So this is designed for compliance reporting and audit prep. Think for stuff like SOC 2 or ISO 27001. It doesn't provide insights into AI fairness, transparency, or any monitoring models. Okay. Next question. A growing e-commerce company is considering migrating its infrastructure to the cloud to improve operational efficiency and scalability. The leadership team is evaluating the benefits of cloud computing, such as cost savings, flexibility, and enhanced collaboration, but wants to understand the specific advantages that cloud services can offer over traditional on-prem infra. So what are the three answers? Go global in minutes and deploy applications in multiple regions around the world with just a few clicks, benefit from massive economy of scales, and trade capital expenses for variable expenses. Or operational. All right. So what is that? Why are these correct? All right. Global in minutes. With cloud computing, companies can deploy applications globally with just a few clicks. This reduces latency, improves user experience. It's just fantastic. Economies of scale. Okay. So AWS aggregates resources across millions of customers, leading to lower costs and greater operational efficiency. And then trading CapEx for variable expenses. Um, so cloud computing removes the need for upfront investments in infrastructure. Instead, businesses pay only for what they use. So why are the other ones incorrect? All right. So are spending money on building and maintaining data centers? No. Cloud computing eliminates the need to manage physical data centers. AWS handles this. So customers focus on what's in the cloud, not the actual infrastructure. Trade variable expense for capital. This reverses the right concept. So cloud computing trades CapEx for OpEx, not the other way around. And then allocate a few months of planning for your infrastructure capacity needs. No. I mean, with AWS, you can plan in minutes if you really need to, but you can scale up or down on demand. So this avoids long-term capacity planning. All right. Next question. A financial institution is designing an AI system on AWS to process sensitive customer data for fraud detection. The company's data engineering team is focused on securing the AI pipeline and ensuring that both data access and data integrity are maintained throughout the process. To implement proper security measures, they need to understand the distinction between data access control and data integrity. What's the correct answer? Data access control involves authentication, authorization of users, whereas data integrity ensures the data is accurate, consistent, and unaltered. All right, so why is this correct? So data access control refers to who can access the data and what actions can they take. This is due to authentication, like verifying your identity, and authorization. What permissions do you have with that data? And then data integrity refers to the accuracy, consistency, and trustworthiness, right? So this prevents unauthorized alteration of data during storage, processing, or transmission. So why are the other ones incorrect? So data accuracy and data access control and integrity are both concerned with encrypting data? No. Okay, so this inverts the roles. No, I'm sorry. Sorry. While both benefit from encryption, their primary functions are different. Access permissions versus data reliability. And data access control is responsible for data encryption. So this is misleading. Encryption is a broad security measure and not solely managed by access control. Also, auditing and logging relates to monitoring, not data integrity. And then data access control and data integrity are both concerned. Oh, I'm sorry. Data access control ensures the accuracy. No. So this inverts the roles, right? So access control governs who accesses, doesn't ensure data accuracy. Next question. Okay. A healthcare analytics company is exploring the use of foundational models to automate the processing of labeling vast amounts of medical data, like patient records and clinical notes, to enhance its machine learning models for diagnosis and treatment recommendations. The company wants to understand the specific techniques that foundation models use to generate labels from raw input data, helping streamline the data annotation process without requiring extensive manual effort. So, self-supervised learning. So why is this correct? So self-supervised learning is a core training strategy by foundation models. Unlike supervised learning, which requires a lot of human labeled data, self-supervised learning generates labels from the input data itself. So this lets a model learn from massive data sets with minimal manual intervention. So this is crucial when dealing with a lot of unstructured data sets like medical records or clinical notes. So foundation models trained this way learn by solving pretext tasks like predicting missing words, reconstructing corrupted inputs, and allows them to build a generalized understanding without labeled data sets. So why are the other ones incorrect? Unsupervised learning. All right. So this requires this doesn't generate labels. All right. So this is used for like clustering, dimensionality reduction, or anomaly detection, but not for labeling raw data for downstream machine learning models. All right. Supervised learning. Okay, so this requires explicit labeled data provided by humans. It's not practical for large scale data like clinical notes without extensive manual labeling. And then reinforcement learning. Okay, so this involves agents taking actions in an environment to maximize the reward, right? So this is not applicable to passive labeling or foundation language training. All right, next question. A robotics company is developing an AI system to improve the autonomous navigation of its robots. The team is exploring deep learning to enhance the system's ability to recognize and respond to its environment. To ensure the AI model performs well, the team needs to understand how model training works in deep learning, specifically the process through which the model learns from large data sets by adjusting its internal parameters. This understanding is essential to optimizing the model for real-time decision making. So, model training in machine learning involves using large data sets to adjust weights and biases of a neural network through multiple iterations, using techniques like gradient descent to minimize the error. So why is this correct? All right. So in deep learning, training a model means presenting it with large labeled data sets and allowing it to learn patterns by adjusting the weights and biases in its neural network architecture. The training process uses optimization techniques like gradient descent, which calculates the loss or error, right? So this is how far the prediction is from the actual results and adjusts the weights to minimize that error over time. So this process happens over multiple iterations. So this helps improve the model's performance with each pass through the data. This training lets the AI system generalize well to the real world. So unseen inputs would be critical for any autonomous navigation going forward. So why are the other options incorrect? Okay, so model training and deep learning requires no data. Okay, so deep learning depends heavily on data. So this is good for pattern recognition and learning. So no data means no training. So model training and deep learning involves manually setting them. No. Okay, so this is not scalable. It's not effective, right? So deep learning models automatically learn weights using back propagation and optimization algorithms like gradient descent. And okay, model training involves only the use of support vector machines. So these are traditional machine learning algorithms, not deep learning. So deep learning is centered around neural networks, which can model complex hierarchical relationships in data. Next question. Okay. A software company is developing a generative AI model for language translation and needs to optimize the way the model processes and understands text. The development team is focused on improving the model's ability to convert words into a form that the AI can effectively interpret and generate accurate translations. To achieve this, they need to clarify the roles of tokens and embeddings in the model's language, the model's language processing. Okay, what's the answer? Okay. A token is a sequence of characters that a model can interpret or predict as a single unit of meaning, whereas an embedding vector of a numerical values that represents a condensed information obtained by transforming input into that vector. All right, so why is this correct? Okay, so this is a conceptual distinction in Gen AI models, right? So a token is a unit of text that the model processes. It can be a full word, a part of the word, like a prefix or suffix. It can be punctuation, or it can be common phrases like unbelievable, or that can be tokenized into unbelievable. All right. Then you have embedding. So embedding is a numerical vector representation of a token. So it allows the model to work with words mathematically by placing them in high dimensional space where semantic relationships, so like king to queen or man to woman, those can be captured, right? So this distinction lets the model convert language to numbers via embeddings and then analyze and predict patterns based on those numbers. Okay, so why are the other answers incorrect? So both token embedding versus sequence of characters? No. Okay, so that's incorrect because it treats concepts as textual rather than distinguishing between like symbolic, something like a token, and numeric, something like embedding, right? Which are those type of representations. So embedding is a sequence of characters that a model can interpret or predict as a single unit. So this reverses the roles. So embeddings are not the character sequences. They're the numerical vectors, and these are derived from character or token sequences. And then both token and embedding revert to a vector of numerical values that no. So this falsely equates both to embeddings. So it ignores the fundamental difference between tokenization and vector representation. Okay. All right, next question. A machine learning team at a tech company is developing a Gen AI model to automate text generalization for customer support. As part of optimizing the model's performance, the team needs to adjust both model parameters and hyperparameters, but wants to clearly understand the distinctions between the two. Understanding these differences is crucial for fine-tuning the model and improving its output. So, the answer. Model parameters are values that define a model and its behavior in interpreting input and generating responses. Hyperparameters are values that can be adjusted from model customization to control the training process. All right, so why is this correct? All right, so model parameters are learned during training, and these define how a model behaves. So an example could be the weights or the biases in a neural network. So these are the internal and they're adjusted automatically through training, right? So think back propagation. And then hyperparameters. These are manually set before training and guide the training process itself. So examples might be like learning rates, batch sizes, number of layers. These are not learned by the model, but significantly influence the model performance, right? So AWS Bedrock would say the hyperparameters are external configurations that control the training process, and model parameters are internal variables learned during training. All right, so why are the other ones incorrect? Hyperparameters and model parameters are that define a model and its behavior and interpreting and input. Okay, so hyperparameters control how training happens, not how the model interprets input or output during inference. All right, hyperparameters are values that define a model and its behavior and interpreting input and generating responses. So this reverses it. Okay, so model parameters define behavior, hyperparameters guide training strategy. All right, both hyperparameters and model parameters are values that can adjust for model customization. No, this is misleading. Okay, so hyperparameters are adjustable before training. Model parameters are adjusted by training, not manually. Okay, next question. All right. A financial services company is deploying AI models to assess credit risk and make lending decisions. As part of ensuring ethical AI use, the company wants to build models that are both interpretable and explainable to regulators, stakeholders, and customers. The data science team needs to understand the distinction between interpretability and explainability in the context of responsible AI to choose the right techniques for transparency. This distinction will guide the company in making its AI models more trustworthy and compliant. Okay. Answer is interpretability is about understanding the internal mechanisms of a machine learning model, whereas explainability focuses on providing understandable reasons for the model's predictions and behaviors to stakeholders. So why is this correct? So interpretability, this refers to how well a human can understand the internal workings of a model. This means the weights, the feature importance, the structure. Explainability focuses on communicating why the model made a certain prediction in a way that is understandable to non-technical people. Think like customers, auditors, or regulators. So in high-stake industries like financial services, this distinction is critical for complying with regulations. Think like fair lending, and it helps to maintain user trust. Okay? So why are the other answers incorrect? Explainability is about understanding the internal no. So this reverses it. So this swaps the definitions of the two concepts. And then let's see, interpretability refers to the ability to understand technical details of the models. No. Okay, so this misrepresents both terms, right? So interpretability is not limited to code, and explainability does not mean reproducing results. Okay? And interpretability is used to enhance the model's performance. Ew, no. Interpretability and explainability primarily relate to transparency, not performance tuning or security enforcement. Okay, next question. Oh, was that it? All right. I guess we're done. I set a certain timetable, and we're good for this day. All right. So we're gonna come back and go over this again for the next one, part 5. But I hope you enjoyed this and learned something. Now, before we go, get ready to schedule an exam. I'm going to take mine shortly. But before you do that, hit the like button, subscribe, and share this to anyone you know who's taking the AWS AI Practitioner exam. Until then, have a good day.